Hi, I'm Gail. Let's work together, do our best to learn as much as we can, and respect and support each other through all the challenges. Come on, let's do this! The learning objectives are how to calculate z-scores, how to read the z-table, how to calculate the areas under the curve, to the right, to the left, and in between z-scores. What is z-score? A z-score is a numerical measurement that describes a value's relationship to the mean of group of values. Z-score is measured in terms of standard deviation from the mean. If a z-score is 0, it indicates that the data point score is identical to the mean score. How to calculate z-score? The formula for calculating a z-score is Z is equals to x minus mu over sigma, where x is the raw score, mu is the population mean, and the sigma is the population standard deviation. As the formula shows, the z-score is simply the raw score minus the population mean divided by the population standard deviation. Z-table. Example: a z-score is equals to negative 1.83 has an area of 0.0336. To say this in a more formal manner, we can say that the proportion of z less than negative 1.83 is equal to 0.0336. We can also use the standard normal table to determine the area to the right of any z value. All we have to do is take 1 minus the area that corresponds to that value. 1 minus area left is equals to area right. For example, to determine the area to the right of a z-score of 0.67, find the area that corresponds to the set value and then subtract it from 1. According to the table, the z-score of 0.67 has an area of 0.7486 to the left of it. So, 1 minus 0.7486 give us an area of 0.2514. Example: suppose that we gathered data from last year's final chemistry exam and found that it followed a normal distribution with a mean of 60 and a standard deviation of 10. We will use the formula of standard normal deviation. The value of the mu is equals to 60 and the value of the sigma is 10. We can take each value of x and plug it into the equation and it will result to standard normal distribution. The mean of the normal distribution will always be converted to 0, and the standard deviation will always correspond to a value of 1. The proportion of x less than 49 is missing until we use the standardization formula. After substituting 49 into this formula, we end up with the value of negative 1.1 as a result. Now, we can use the z-score table to determine how much the area is associated with z-score. According to the table, there's an area of 0.1357 to the left of this set value. This means that the proportion is less than negative 1.1 is 0.1357. This value is in fact the same proportion of individuals that scored less than 49 on the exam.